Okay, so let's do another round of finding equations given information. What's different about this is it's a little more wordier, right? So there's not a picture, there's not a table of data, there's a lot of words. And so let's take a look at these situations. Some new ideas, maybe old ideas come up. And before we do anything, what I want to also point out is there's the buzzword parallel and perpendicular, right, are playing a role in many of these things. A parallel basically means I have two lines that are running right by each other, not intersecting. What it means is the slope is the same. So the slope of this line is the same as the slope as that line. So that's what that means. That was the easy one. Perpendicular, it's a little tougher. What happens when I have perpendicular lines is that they're intersecting at a 90-degree angle. And it turns out that the slope here, right, is basically the opposite reciprocal of the slope there. So, in essence, to be perpendicular, right, the slopes are opposite reciprocals, right? And then again, that's hopefully something you guys remember from previous work. So, new language, parallel, same slope. Perpendicular, opposite reciprocal slopes. Okay, so let's go ahead and go to work on this. So now what I'm also doing is I'm actually asking you for a particular type of equation. I'm not giving you free rein. I'm telling you exactly which one I want. So I'm asking you for y equals mx plus b. So what do we need? I need the intercept and I need the slope. Find those two things and I just plug them in and I'm done. So I'm asking for y equals mx plus b. I want the slope-intercept equation of the line that passes through the point 0, negative 3. Well that's pretty cool, right? So 0, negative 3, that's a y-intercept. So we already know that b is negative 3. So we're halfway there, right? So we just need the slope. So let's keep reading, all right? So not only does this line pass through the point 0, negative 3, right, and it is parallel to the line that passes to the point negative 2, 4, and 4, 5. All right, so the first thing we got to kind of decipher here is the fact that there's actually two lines. The one I'm trying to find, right, so matter of fact, let me try drawing a picture here. So the one I'm trying to find is going through 0, negative 3. The other line passing through two other points, negative 2 and 4, and 1, 2, 3, 4, and 5. So this is the line, right, that's given, and you can already kind of see in this case that we just need to match the slope. So there's two lines here. So if I can find the line that's passing through these two guys, then I know because they're parallel, I basically have the line I'm trying to find here. So, right, here's x1 and y1 and x2 and y2. My slope is 5 minus 4. And I think we get 4 minus a negative 2. So we get 1/6. So my slope is 1/6. So our line, y equals mx plus b, is y equals 1/6x plus negative 3. Of course, you'll probably see that in the back of the book as 1/6x minus 3. So that's probably the final answer there. So the line we're after, right, this line right here, right, will have a slope of 1/6 and go through negative 3. It'll be parallel to the line, right, that's going through negative 2, 4, and 4/5. So running right across it. So there you go. So again, the information that we need is mixed in all the language. It's just not a nice, neat graph, or it's not a nice, neat table. We got to pick the data points out. Number 4, again, I'm asking for slope-intercept. So again, we have y equals mx plus b. We've got to find the y equals mx plus b, or the slope-intercept equation of the line that passes through 0, negative 3 again. All right, so again, we already know b is equal to 3, but this time we're perpendicular to the line that passes through negative 2, 4, and 4, 5. So we essentially have the same problem, but the difference is we're no longer parallel, right? We are passing through this, and we are perpendicular to it. All right, and what did I say about slopes that are perpendicular? Well, if my slope is 1/6, this means a perpendicular slope will have to be the opposite reciprocal. So in this case, negative 6. So we have everything we need. My y equals mx plus b is y equals negative 6 right, plus a negative 3. Of course, that would probably be negative 6x minus 3 in the back of the book. And so there you have it. All right, so we've basically found our two slope-intercept equations based off of the information that we have. Okay, so number 5. This time I'm asking for find the point slope equation. So again, I'm telling you what I want. I want us to find this guy, right? And it's the point slope equation of the line that passes through the point negative 3, 4. Well, lo and behold, I've given you almost everything you need, right? Our x1 and our y1 is basically negative 3, 4. So I know x1 and I know y1. So what's missing is that slope. But what are we told? Well, we got to find the slope, the point slope equation of the line that passes through this and is parallel to this line given by this equation. So again, you have to realize there's two lines. The one I'm trying to find, right, again, if I had to draw a picture, we're passing through negative 3, 4, right? So there's negative 3, 4. And then there's some other line given by that equation that we're going to be parallel with. All right? And again, what does it mean to be parallel? My slope's the same. So if I can find the slope of that line, by default I have the slope of the line that I'm trying to find. So how do I find the slope of the line given by 2x minus 5y equals 10? Well, maybe the quickest and easiest way is just to rewrite it in a more useful form. So how about I subtract 2x from both sides, divide everybody by negative 5, and we get 2/5 x minus 2. And there's your slope. So our slope has to be 2/5. So plugging everything in, we get y minus 4 equals my slope, x minus a negative 3. So I'm just literally plugging in my y1 value, my slope value, my x1 value. If we clean that up, we get y minus 4 equals 2/5 x plus 3. And there's our answer for part 5. All right. Part 6, we got to find the point slope equation of the line. So again, we're looking for y minus y1, m x minus x1, right? That passes through the point negative 3, 4. So we still have the same data point, right? But this time it's perpendicular to the line given by 2x minus 5y equals 10. So again, two lines, but this time rather than being parallel to this line, we're perpendicular. But we already know what the line is here, right? The slope of this line that's given is 2/5. So the perpendicular slope would be the negative reciprocal, or negative 5/2. And there you have it. We have what we need. So going here and plugging in what we know, we got y minus 4 equals negative 5/2 x minus negative 3. Cleaning that up, cleaning it up, y minus 4 that equals negative 5/2 x plus 3. All right, and there you have it. So we got it. The next one, right, is a little challenging. We have to find the slope-intercept equation of the line that passes through the points 1, 2, and negative 7, 4. So the good news is there's not two lines. The bad news is neither one of these points that are given, neither one's the y-intercept. And they're asking for the slope-intercept equation. So there's our first challenge. So how about, why don't we go ahead and first, right, because there's three ways to represent this line, why don't we first use one that's useful, right? Here's my x1 and y1, and my x2 and y2. So I already know x1 and y1, we just need to find the slope. So using my slope formula, right, we got 4 take away 2 and negative 7 take away 1. That's 2 over negative 8. So it looks like my slope is negative 1/4. So here's my slope, there's my x1 and y1. So if I just plug that information in, there's where we go. So the good news is I have an equation that represents the line. The bad news is it's not in the form that I want. So let me come over here, and all we have to do is basically solve for y, right? And that'll get the trick. So I'll first start by doing a distribution, right? So if I distribute this, I get negative 1/4 x. A negative times a negative is a positive. 1/4 times 1 is 1/4. All right, we're going to add 2 to both sides. But over here, right, we have fractions, and this, right, is 2 over 2, so we get 4 over 2. So we get y equals negative 1/4 x, 1/4 plus 4. I goofed up. This has to be 4 over 4, so that's an 8. So 1/4 plus 8/4, right, is equal to 9/4. And there's your y equals mx plus b. So there's the answer that we have. So again, this is a pretty powerful form, all right, when you don't have the y-intercept. You can start with it, and then you can leave it there like we've done in the past. Or if they're asking for the slope-intercept, just use your algebra skills, your formula solving skills, all right, to basically solve for y. And that's a pretty interesting y-intercept, right? 2 1/4 is where we would find that. Okay, so we're almost 11 minutes into this. We have much more to do. Let me stop there, and we'll continue to find equations of lines given information.